Okay, so this is again a very short video just to answer a specific question. The paper is the Cambridge A-Level 9618 syllabus, paper 1-3 of October-November 2022. The following table shows part of the instruction set for a processor. The processor has one general purpose register, the accumulator, and index register IR. Now, we know that the operators or the instructions or the mnemonics used are all hypothetical, they're all imaginary. Now, basically, the current contents of main memory and selected values from the ASCII character set are given. Trace the program currently in memory using the trace table. So this is the program in memory. This is the memory address, 75, 76, 77. This is the memory address. The instructions are this, complete instructions. So let's see. Okay, so the program starts at line 75. Line 75 is LDR hash 0. So 75, instruction at 75 is 0 at this point in the index register. 76 is the next one. Load directly, that means the contents of 100 into accumulator, right? 77, compare the two. Compare value 2 with number 1 in accumulator. It's not equal, so it's not going to run this line. Now it comes to 79. 79 says load with indexed addressing the contents of 110. So 110 plus 0. 110 is this. 110 plus 0 is still 110. So line number 79 is going to load the contents of 90. Is going to load the contents of 110, which is 97, into accumulator. So we have 97 here. Subtract the value 32, that's 80. Subtract value 32 from 97. That means accumulator has 97. Take off 32, 5, 6. The answer is 65. 80, subtract 32 from that 97, and the answer remains in the accumulator. Next, 81. Compare hash 65. Yes, it's equal. 82. JPN, jump if not equal. It's not going to jump. 83. Load immediate value 1. Load immediate value 1. 84. Add 101. So accumulator still remains at 1. Store that value in 101. 101 still has the value 0. Sorry, that was the next line. Store that value in 101. 101 is here. That same one comes here. Next, 86. Load immediate value number 1 in accumulator. 87. Add 100. 100 is 1. So add 1 to this one, you have 2. 88. Store that value in 100. Now 100 is this column. This column. So the number 2 is here. Yes. Then 89. Increment index register by 1. Which column is index register? The second one here. So index register becomes 1. Then 90. Jump to 76. So you go to 76. Unconditional jump. Now what is 76? Load 100. Load 100. 100 is 1. No, 100 is 2. So bring that 2 to accumulator. Then 77. Compare it with 2. So it is equal 78. 78. Jump if equal to 91. So you go to 91. What does 91 say? Load 101. What is 101? This one. It's 1. So load 101, which is 1. Then 92. 92. Add hash 48. So it's going to add 48 to this in accumulator. That means it's going to be 49. Then 93. So what does out do? Let's go back to the instruction. It's supposed to output the screen, output to the screen the character whose ASCII value is stored in ACC. So the ASCII value of 49 is number 1, the character 1. So is there an output column? Yes, the corner, right? So the output is the digit 1, 93, and end. 94 is executed and it's done. Right. So that's it.